Let's watch this player try to score a basket for his team. Do you think he's gonna succeed? Well, let's check it out. Nice shot. But how do you figure whether the ball is going inside the basket or not? And more importantly, what do you call the path followed by this ball? Any guesses there? Well, it's known as a parabolic path and is obtained by quadratic functions. These functions help you to determine the path of a ball for a curved shot or when a cricketer hits the ball in the air. But that's just one of the uses. They are also used to determine how satellite dishes are shaped to focus signals and how the construction of bridges takes place for a perfect and smooth travel. So, are you ready to learn more about quadratic functions and see how math shapes the world around you? Let's dive in. But before we do not forget to like, share, and subscribe to our channel. Welcome everyone, welcome to today's class. In this class, we'll be starting off with our next chapter, that is quadratic functions. As you all know, the first chapter that we completed was functions. Obviously, the next chapter will be quadratic functions. So, let's begin. We'll be starting off with what is a quadratic function, what does the graph of a quadratic function looks like, what is the equation of a quadratic function looks like. All right, so this is an example of a quadratic function. I'm going to write down the standard equation or a standard form of a quadratic function. So fx, the function in x that we have already studied. If you haven't watched our video for functions, please go and watch the video for functions first. All right, so fx is equals to ax square plus bx plus c, where a, b and c are real numbers. Right? Now, some might ask why it is called quadratic. Basically, a quadratic function or a quadratic equation or a quadratic expression is something which has a degree of 2. Now, what is degree? Degree is basically the highest power of the variable. I know most of you might already know all of this, but we'll be starting off with very basics. All right, that's why I'm telling you all these things. So this is an example of a quadratic function because it has a degree of 2, and degree is the highest power on the variable, and we can see that x is the variable and the highest power on it is 2. That's why it is known as quadratic. All right, okay, now coming to the graph. If you'll plot the graph of this equation, it will look something like this, right? Now, what is it called? It is called as parabola. The graph of a quadratic function always looks like sort of a U-shaped. You can see it is kind of a U-shaped graph, and that's why it is known as a parabola. All right, so please note it down and then we'll be moving on. All right, so let's move on to the next topic, that is maximum and minimum value. And how do we find out the maximum and minimum value? So the general form of a quadratic equation is this, that I have already told you, right? Now here a, right, a is the coefficient of x square, and a determines whether my graph will be something like this or something like this. Now this is known as U-shaped opening upwards, this is U-shaped opening downwards, or you can just directly say shape graph of equation opening upwards, graph of equation opening downwards. That's it. All right, okay, now how and what affects it? The value of a affects the shape of the graph. Now the note here, tells me this case. First case, that is if a is greater than 0, then the graph is opening upwards, or I can say it is U-shaped, right? When a, okay, this is less than 0, my bad, it's okay, it's not this, a is less than 0, then the graph is opening downwards, or I can say inverted U-shape. All right, so when a is greater than 0, it is U-shaped, or you can say opening upwards. When a is less than 0, it is opening downwards. Yes, opening downwards, and this is opening upwards. That is the main difference between the graphs. All right, and it all depends on the coefficient of x square, or rather than learning for a greater than 0 or less than 0, you can just check whether the term x square is positive or negative. If it is positive, that's the shape of my graph. It is negative, then this will be the shape of my graph. All right, no big deal, because the actually the term with the highest power will determine the shape of my graph for quadratic function. All right, so that's why only a will be determining whether I'll be getting upwards or opening downwards graph. All right, so please note it down, make sure you're noting these 2 points specially. All right, okay. All right, so let's move forward with the next slide, and that is we have an example, and basically we have to find out in this whether the graph is opening upwards or it is opening downwards. All right, a very easy thing. If I compare this with compare with ax square plus bx plus c, I can say a is 1, since a is greater than 0, graph opens upwards, graph is opening upwards, it's fine, whatever it is. All right, now for the next one, all right, for the next one I will say that compare with ax square plus bx plus c, a is equals to -2. Always remember, never just say that the first term is your x square term, or the coefficient or the constant is your a. All right, the coefficient of x square is your a, so please keep that in mind. All right, so a is -2, so a is less than 0, therefore graph is opening downwards, graph is u shape, something like that. All right, you can write opening upwards kind of thing also, you could have written u shaped also, both are going to be correct. All right, please note it down. All right, before we move on, please, if I'm ever solving a question, if there are 2 questions, make sure that you do the first question, like you see the first question while I'm solving, and for the second question you're pausing down the video, you're solving it yourself, you're trying it to take 2 minutes, 3 minutes, 5 minutes, doesn't matter, it's fine, but please try to solve it yourself. All right, okay, moving on to the next one, that is line of symmetry, vertical line of symmetry, and why is it used and what is the purpose of it. So graphs of all quadratic functions have a vertical line of symmetry. All right, so what is a vertical line of symmetry? A line that divides the graph or divides any shape into 2 equal parts, right? If I'll just fold my graph along this line, it will exactly overlap the other part of the graph. That's what a line of symmetry is. All right, okay, next, if the graph crosses the horizontal axis. If it says if, why it says if? Because there might be a graph which doesn't crosses x axis at all, right? In most of the cases, yes it will, but there might be some cases when it's not even going to touch the x axis. All right, okay, so let's remove this for now. All right, let's continue. If the graph crosses the horizontal axis, then the line of symmetry is halfway between the 2 points of intersection. Now what does it mean is, the points where the graph will cut the x axis, take the midpoint of that, and my line of symmetry or my vertical line of symmetry is going to pass through that point. If I'll take these points, my graph passes through 1 and 3. Yes, so my vertical line of symmetry or my line of symmetry should pass through midpoint of 1 and 3. And what is the midpoint of 1 and 3? Obviously 2. So my line of symmetry is passing through 2. That's what this definition says. All right, the maximum or minimum value lies on this line of symmetry, meaning this is the minimum value of the graph, right? It's very obvious, this is the minimum value. Now when the graph will be u-shaped, that is this in this case, right, such shape, I'll always have a minimum value. Okay, when I'm talking about the minimum or the maximum value, I'm always talking about the output or the y values, right? In this case, if you'll notice, if I extend this downwards, let's say, okay, so if I join this somewhere, so my graph will, let's say, intersect y axis at this point, right? It cannot go below that, obviously, but if I'll check for the maximum value, this graph keeps on going on both sides, right? So I don't know what is the maximum point on the y axis, right? But I do know that this is the minimum point. So whenever I have a greater than 0 or a u shaped, I have always a minima or minimum value. When I have a less than 0, my graph will be something like this, right? Inverted u, and I'll have always a maximum value. All right, please do remind this is a very small thing, but we need to remember this. All right, now what does the note say? This point is often referred to as the turning point of the curve. This is very obvious, right? Let's say I'm starting from this point, right? I'm coming down, 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 and at this point I start moving up. So the graph took a curve, the curve took a turn, right? Or the graph took a turn from coming down to going up. That's why this point, the minimum value or the maximum value, is always known as the turning point. It has one more name, stationary point. Now since we are doing add maths, and many of you might know what is a gradient or slope, you might be like aware of these terms. So it is known as stationary point because the slope or the gradient of this point is 0, or I can say the gradient of the curve at this point is always 0. That is why this is known as stationary point. I can tell you one more way to remember this name. If I drop a ball from here, right, and let's assume that the ball is not going to cross over, so at what point is the ball going to stop? Obviously at this point, right? So that's why at this point my ball is going to be stationary. That is why this point is known as stationary point. All right, please note it down. All right, let's move on to the next one and let's solve an example. Again, please pause this video. We have one question, so please pause this video, try it yourself, and then resume the video just to check out your solution. All right, for the equation y equals x square minus 4x minus 5, identify the values of x where the curve intersects the horizontal axis. All right, so let's do that. Let's find at what points my graph will touch the x-axis. So when it will touch the x-axis, I can say that the y coordinate is going to be 0. Yes, so let's put y as 0. My equation will be x square minus 4x minus 5 equals to 0. Correct? All right, so let's use splitting the middle term. X square minus 5x plus x minus 5 equals to 0. Let's take out x common. Correct. Now the product of two linear factors is 0. So either of the linear factor has to be 0. So x can be 5 and x can be minus 1. So these are the 2 points, or I can say that minus 1 comma 0 and 5 comma 0 are the points where the graph intersects the x-axis. That's my first part. Now the second part, hence find the coordinates of the maximum or minimum point. Now how to do that, right? Okay, if I'm drawing the rough graph here, okay, since the graph has x square or the coefficient of x square greater than 0, right? So I can say my graph should be something like this, right? All right, another thing, the graph intersects the x-axis at 5 and minus 1. So this is minus 1 and this is, let's say, 5. My graph should look something like this. Yes, everyone agrees with me? All right, now one more thing, let's draw the vertical line. Yes, and this vertical line will pass through this maximum, right? But it will also pass through the midpoints of these two, right? Let's say this is point A, point B, and this is point C. So how to find coordinates of point C? Let's find the midpoint of these two, that is 5, or minus 1 plus 5 over 2, that is 4 over 2, that is 2 comma 0. So the coordinates of C is 2 comma 0. Yes, all right. Now just one more minute. Okay, on a vertical line, let me repeat again, on any vertical line, the x coordinate always remains same on the entire line. What I mean to say is, if you'll pick any point on this dotted line, blue line, the x coordinate on the entire line is always going to be 2. So the x coordinate of this point should also be 2. Yes, but this point also lies on the equation, right? So let's put x as 2, and obviously it's going to be minimum, right? So minimum value going to be y equals 2 squared minus 4 times 2 minus 5, that is 4 minus 8 minus 5, that is minus 9. So I can say that the coordinates of this point is 2 comma minus 9, but the question didn't ask me the coordinates. It asked me, acha, okay, it did ask me the coordinates. So the coordinates are 2 comma minus 9. Always remember that the minimum or the maximum value is the y coordinate, and to find the y coordinate we do need the x coordinate of the point. All right, I hope you were able to solve this, at least the first part, but if you solved both the parts correctly, Hats off to you people. All right, please note it down, those who weren't able to solve this completely. All right, let's move on to the next slide. We have factorization. Now, we have already used factorization in the previous question, and I know nearly all of you knows how to do factorization, but we are still going to do it. Now, we have a quadratic expression. All right, before we start off, let me tell you, factorization can be used for quadratic as well as cubic, but we cannot use factorization directly in cubic expressions. So somehow we try and convert the cubic equation in quadratic and then use factorization. All right, okay. We have a quadratic equation in which a is equals to 1, b is equals to 1, and c equals to minus 6. For those who don't know how to solve factorization questions, let me just give you a detailed analysis or detailed study. First of all, compare this with ax square plus bx plus c. From that we get a as 1, b as 1 and c as minus 6. That's your first step. Second step is find a times c, that is minus 6. Correct? After that, your third step is divide b into two parts. Let's say b1 and b2. How? Such that b1 plus b2 should be equals to b, and b1 times b2 equals to a times c. Correct? So I need two numbers so that their sum is 1 and their product is minus 6. Try and find two numbers whose sum is 1 and product is minus 6. So those two numbers are going to be c and minus 2. Correct? Now you might ask, sir, we could have also taken minus 3 and 2. Why not? Because if you'll add minus 3 and 2, you are going to get minus 1, but we need plus 1. All right. So your function is going to break into x square. The x term will break into these two, plus 3x minus 2x minus 6, that is equals to x plus 3 minus 2 plus. Also another hint, that have you broken it into correctly or not. When you have split it into correct terms, these two brackets are always going to be same. All right, that is equals to, take out the entire bracket common, and we are left with this, and that's the factorization of x square plus x minus 6. All right, yeah, so please note it down. All right, let's move on to the next one. Now, completing the square method. This is very important. Important as in, it's a little bit difficult. All right, according to your exam point of view, it's not. All right, there is a very rare chance that you get a question related to completing the square method, but if it does come, it's going to be tricky. So we need to focus our 100% attention right now. All right, let's assume I have a quadratic expression ax square plus bx plus c. Yes. Now what's the first step? My first step is, I'll be making the coefficient of x square as 1. That is, I'll divide the entire equation with a, or you can say I'll take out a common from the entire equation. Right? See, coefficient of x square needs to be 1. If not, take it as the common factor. So if you have a function, quadratic function, in which the coefficient of x square is not 1, take out take out that number as the common factor. All right. So step 2. Okay, I'm going to solve it here. Okay. So if you took it out common, you will get a brackets x square plus b over a x plus c over a. Yes. All right. Now determine half of the coefficient of x. So what is the half of coefficient of x? b over 2a. Correct. Now step 3. Add and subtract the square obtained in step 2. This is my step 2, right? So add and subtract the square of it. A times x square plus b over a, b over ax plus c over a plus b over 2a whole squared minus b over 2a whole square. Correct? Something like this we'll be getting. All right. Now let's take step 4. Factorize the polynomial and apply the algebraic identity x square plus 2xy plus y square or x square minus 2xy plus y square. So basically, always remember the x square term, all right, and the plus term of that you added, and this term, all right, the term containing x, right, will give you the whole square thing. Now how to figure out whether it is x plus y whole square or x minus y whole square? Just a short trick. This is your first term x, this is your second whole square term, that is b over 2a, whole square of it, always. Now the only thing remaining is whether it is plus or whether it is minus. How to figure it out? Using this term. What is the sign of the term containing x? Plus. So that's why it's going to be plus. That's all. End of story. All right. So that's how I'm going to solve my question. Now you'll be having doubts, sir. What about these two things? Yes, you'll have them and we will be solving them one by one. All right. But for now, you need to remember how did we actually get the square, right? And this is very important, that there are x square and the plus term of b over 2a whole square. We'll be taking them inside the square and the sign of the term containing x. That's it. All right. So please note it down. Make sure to write down all the steps. For now, you'll not be needing them in exam, but for now please do them, and side by side please solve this also. All right. Let's move on to a question. Right now, write x square minus 8x plus 18 in completed square form. That's my first question. State whether it is a maximum or a minimum. Then the third part is sketch the graph of y equals to fx. All right. So the first is, let's write this in a, okay, let's first solve the second part, whether it's a maximum or a minimum. It's very obvious that it is going to be a minimum. Why? Because the term of the coefficient of x square is 1, which is greater than 0. Now let's come to the main point, that is x square minus 8x plus 18. My first step was make the coefficient of x square as 1. It's already 1, so I need not to worry about it. My second step was determine the half of coefficient of x. So the half of coefficient of x, that is 8 over 2, that is 4, right? So the third step was add and subtract the square of it. So I'll be getting x square minus 8x plus 18 plus 4 squared minus 4 squared. Yes. The next step was to make the x plus y or x minus y whole square. Remember? Now what did I tell you? X and this will give you your whole square, correct? Then the sign of the term containing x, that is minus 4, but that's not the complete answer. You still have something left, some constant terms. Now what are the constant terms? These two. Yes, so you have plus 18 minus 4 square, that is 16. So that is x minus 4 whole squared plus 2. All right, so that's your answer. Now the question might have asked, what is the maximum or minimum value? In this case, what is the minimum value? How to figure it out? Very easy. If you have found out the whole square, it's really easy. Now how? Let's just check this part. All right, x minus 4 whole square. Now tell me, we need to find the minimum value, right? So what is the minimum value of x minus 4 whole squared? Isn't it 0? Because it is a square, it has to be positive or 0. So I can say that the minimum value of this part is 0. If I add 2 to it, what should be the minimum value? Minimum value should be 2. And at what value of x are we going to get y as 2? At x equals to 4. Now why 4? Because at x equals to 4, this part will become 0 and I'll get the y as 2. Alright, please note it down, then we'll be moving on to sketching of the graph. Alright, now let's move on to sketching the graph. Now there are two ways to sketch this graph. What was your initial equation? X square minus 8x plus 18. My initial equation was y equals x square minus 8x plus 18. Yes? Alright. Now, we all know that the minimum value, okay, first let's draw this. Let's take 2, 4, 6 and let's take this as 8. It's fine. 0, minus 2, minus 4, minus 6, minus 8, 2, 4, 6 and 8, minus 2, minus 4, minus 6 and let's say minus 6. Now, we all know that the minimum value of this graph was at x equals to 2. Sorry, y at was y2 at x equals to 4. All right. Now, what we can do is we can just try. Your another equation was y equals x minus 4 whole squared plus 2. Now, if I put x as 4, I am getting y as 2. Correct? All right. Now, let's put x as 5. All right. If I put x as 5, I'll get y as 3. So 5 comma 3 somewhere be here, and if I'll put x as 3, I'll also get y as 3. All right. Now try putting different values of x. Let's put x as 6 now. All right. If I'll put x as 6, so 6 minus 4 is 2. 2 squared is 4 plus 2, 6. So at x equals to 6, y is 6. Similarly, at x equals to 2, again y will be 6. Okay, so basically what we have done is we have drawn a table with multiple point values x and y. So at x equals to 4, y was 2. At x equals to 5, it was 3. At x equals to 3, it was again 3. At x equals to 6, it is 6. At x equals to 2, it is again 6. So now let's just join these values and something like this is going to be my graph. Now remember, in the starting of this video I did tell you that there might be some cases where the graph is not touching the x-axis. This is one of the examples where the graph is never going to touch the x-axis. It has a minima, but still it will never touch the x-axis. All right, please note this down. All right, let's move on to a small note. All right, what does the note say? The set of values of x is called the domain of the function, and the corresponding set of y values is known as the range. So let's get back to this table. All right, so all these values were the domain, and all these values were the range. So the domain is the set of x values which I can put in the function. And what did I say, which I can? Because there might be some values of x which cannot be substituted into the function. And why not? Because at those points my function will become undefined. Again, this is one of the topics that we have discussed in detail in the previous chapter. All right, so please note this down. All right, note this down, please. All right, everyone, so that's the end of this class. I hope all the topics that we have discussed today are crystal clear. So we'll be meeting in our next class, and in that we'll be discussing the upcoming topics of the same chapter. All right, so but before we go, please do not forget to like, share and subscribe to our channel. Thank you. If you had a blast watching, give us a thumbs up, share it with your friends and subscribe our channel to stay updated on all our future videos.